You spent good money on a turbocharged Toyota. Whether it is a RAV4 with the 2.5-liter turbocharged four-cylinder, a GR Corolla with the G16E GTS, or a Supra running the B58 inline 6, that turbocharger is the most stressed, most expensive, and most abused component in your entire drivetrain. And most owners are destroying it slowly, one bad habit at a time, without ever knowing it. Here is what makes this worse. The damage does not happen overnight. It builds invisibly over months. Your car keeps running, feels mostly fine, and then one day you hear a whine, a clatter, or you lose boost, and the repair bill lands between $2,000 and $4,000, sometimes more. These 7 habits are the exact reasons that happens. Stop doing them, and your turbo will last the life of the engine. Keep doing them, and it is already on borrowed time. Habit number 1. Driving hard immediately after a cold start. This is the single most destructive thing you can do to a turbocharged Toyota engine, and millions of drivers do it every single morning. Here is the problem. The turbocharger on your Toyota, whether the twin-scroll unit on the GR Corolla sitting right off the exhaust manifold, or the low-pressure turbo in the RAV4 hybrid system, spins on a journal bearing that is lubricated entirely by engine oil. When the car sits overnight, gravity pulls oil away from that bearing. The oil film drains down into the pan. The bearing sits dry. At idle after a cold start, your Toyota's oil pump needs between 15 and 30 seconds to fully pressurize the system and push fresh oil up to the turbocharger bearing housing. During those seconds, the turbo is spinning on metal with little to no lubrication. Now add hard acceleration into that equation. When you rev hard on a cold start, turbo speeds immediately jump to anywhere between 100,000 and 150,000 revolutions per minute. That is not a typo. 150,000 revolutions per minute on a bearing that does not have a full oil film yet. The heat generated during that dry spin microscopically scores the bearing surfaces. Each time you do it, more material is removed. The clearances grow. Eventually, the shaft wobbles, the compressor wheel contacts the housing, and the turbo is done. The fix is simple. After a cold start, let the engine idle for 60 to 90 seconds before driving. Then drive gently for the first 2 to 3 miles. Allow oil temperature to climb naturally. This one habit change alone will extend turbo life by tens of thousands of miles. Habit number 2. Shutting the engine off immediately after hard driving. This one kills turbos that are otherwise healthy, and it happens every single day in driveways across America. When you drive hard, for example, when merging onto the highway, towing, or mountain driving, the turbocharger is under sustained load. The turbine housing then reaches temperatures between 1,000 and 1,600 degrees Fahrenheit. The turbocharger center section, where the bearing sits, absorbs that heat by circulating engine oil. That oil does 2 things at the same time. It lubricates the spinning shaft, and it carries heat away from the bearing housing. The moment you shut the engine off, the oil pump stops. There is no more oil flow. The turbo does not stop instantly. The turbine wheel keeps spinning from residual exhaust heat and from momentum. Now it is spinning with zero oil circulation inside a housing that remains extremely hot. That trapped heat cooks the oil that remains in the center section. The oil breaks down, carbonizes, and forms deposits directly on the turbo shaft and on the bearing surfaces. Toyota technicians call this coking. It is one of the most common causes of premature turbocharger failure they see on GR86 TRD builds, modified RAV4 turbos, and Supra daily drivers alike. The fix is a 2-minute cool-down idle before shutdown after any hard driving. Just let the engine idle. Let the oil pump keep moving cooled oil through the turbo center section until temperatures drop. 2 minutes of idling costs nothing. A replacement turbocharger costs thousands. Habit number 3. Running low-grade or wrong viscosity engine oil. Your Toyota's turbocharger does not care about marketing. It does not care about the brand on the bottle. What it cares about is whether the oil film between the spinning shaft and the bearing holds up under extreme heat and pressure. Toyota specifies 0W20 full synthetic on most turbocharged 4 cylinders, including the A25A FXS in the RAV4 and the 2AR FKS in older configurations. The GR Corolla's G16E GTS calls for 0W20 or 0W30 full synthetic under performance driving conditions. The Supra's B58 specifies full synthetic meeting BMW long life specifications. When owners use conventional oil, high mileage blends with incorrect viscosity, or the wrong grade because it was on sale, they are putting a fluid into the turbo system that was not engineered to survive those temperatures. Conventional oil begins breaking down at around 250 to 300 degrees Fahrenheit under sustained heat. Turbo bearing housing temperatures can exceed 400 degrees during normal operation. Degraded oil loses viscosity. The oil film thins out. Metal contacts metal. The bearing begins to wear at an accelerated rate, and nothing about that process is visible until the damage is already extensive. Use the exact oil specification Toyota lists in your owner's manual from a reputable manufacturer, changed at the correct interval. On a turbocharged engine that sees hard driving, consider shortening that interval to 5,000 miles even if the manufacturer recommends longer. Oil is cheap. Turbos are not. Habit number 4. Ignoring the air filter until it looks completely blocked. The turbocharger on your Toyota is essentially an air pump. The compressor wheel on the cold side of the turbo pulls intake air in, compresses it, and forces it into the intake manifold. On the GR Corolla, that compressor wheel spins at speeds that would destroy most industrial machinery. On the RAV4's turbocharged unit, it does the same work at lower intensity, but under sustained load for tens of thousands of miles. Every single particle of dust, debris, or dirt that gets past the air filter goes straight through that compressor wheel at high velocity. The compressor blades are precision machined aluminum, sometimes as thin as a few millimeters at the tips. Even fine dust causes micro-erosion over time. Larger particles cause immediate blade damage. Most Toyota owners check the engine air filter, which sits in the airbox in the front corner of the engine bay and connects to the intake pipe that leads directly to the turbocharger inlet, only when a mechanic mentions it. By then, restriction is already high. A clogged air filter does 2 things that hurt the turbo. First, it starves the compressor of airflow, forcing the turbine to work harder for less output. Second, it creates negative pressure in the intake tract that can pull oil past the turbo seal and into the intake system. That causes turbo seal failure, oil consumption, blue smoke, and eventually bearing damage. Inspect the engine air filter every 15,000 miles on a turbocharged Toyota. Replace it every 30,000 miles or sooner if you drive in dusty conditions. Habit number 5. Ignoring small boost leaks. A boost leak is a gap in the pressurized intake system between the turbocharger outlet and the engine intake manifold. It can be as small as a pinhole in a silicone intake coupler, a loose hose clamp on the charge pipe, or a hairline crack in the plastic intercooler pipe. On the RAV4 Turbo, the charged air path runs from the turbocharger outlet, through the intercooler, down the charge pipes, and into the throttle body. On the GR Corolla, That same path is shorter, but operates at higher pressure. On the Supra, the charge piping is complex and runs across a wide engine bay. Even a small boost leak causes the turbocharger to work harder than necessary. To compensate for lost pressure, the engine control unit commands more boost. The turbo spins faster. Exhaust back pressure rises. Temperatures go up, and the extra cycles of high-speed operation under corrective boost add wear that the turbo was never designed to sustain. Small boost leaks also allow unmetered air into the system, which throws off the air-fuel mixture. The engine may run lean under boost, which is one of the fastest ways to cause combustion damage beyond just turbo wear. Listen for a soft hissing sound under acceleration, especially between 2,000 and 4,000 revolutions per minute. Check all charge pipe couplings, intercooler end tanks, and the connection between the turbocharger compressor outlet and the charge pipe. Tighten any loose clamps. Replace cracked or split silicone couplers immediately. A $15 coupler prevents damage that costs thousands to repair. Habit number 6. Using the engine heavily right before shutdown without a cool down. This is a variation on habit number 2, but it deserves its own category because the specific scenario is different and equally common. Many Toyota owners drive normally for most of a trip, then accelerate hard in the last mile or two, rushing to beat a light, jumping onto a freeway ramp, or making a quick passing move. They arrive and then shut the car off within 60 seconds of that hard acceleration. The turbocharger on your Toyota does not cool down in 60 seconds. Even after moderate driving, the turbine side of the unit retains significant heat for several minutes after engine shutdown. After a hard pull, that heat is extreme, and the coking risk described in Habit 2 is at its highest. The damage is cumulative. One occurrence may not destroy the turbo, but drivers who consistently shut down within seconds of hard driving deposit more and more coked oil onto the bearing shaft with every cycle. The bearing clearances grow, shaft play increases. Eventually, the compressor wheel contacts the housing or the bearing seizes. The practical solution is simple. Plan your drive so you are not accelerating hard in the final moments. Arrive gently. Coast into the driveway. Let the engine idle for 90 seconds to 2 minutes before turning the key. That is the entire purpose of turbo timer devices, but you do not need a device. You just need 60 to 90 seconds of patience. Habit number 7. Neglecting the oil feed line and oil return line to the turbocharger. This is the habit that almost no one knows about, but it is responsible for a significant percentage of premature turbo failures that Toyota technicians see on high-mileage cars. The turbocharger on your Toyota is connected to the engine's lubrication system by 2 lines. The oil feed line, a small high-pressure line that runs from the engine block or cylinder head down to the top of the turbocharger center section, delivers pressurized oil to the bearing. The oil return line, a larger diameter drain line that runs from the bottom of the turbocharger center section back down to the oil pan, allows gravity to drain used oil back into the sump. Over time, both of these lines can develop problems. The oil feed line can develop carbon deposits at its inlet, restricting flow. The oil return line can partially block from sludge buildup, forcing oil to back up inside the turbo center section. When oil backs up and cannot drain freely, it leaks past the turbo seals into either the intake side or the exhaust side of the turbocharger. The result is oil burning, which shows as blue or gray smoke, oil consumption without visible leaks, and eventually bearing failure from inadequate drain back. On your Toyota, these lines are inspectable during routine maintenance. The oil feed line inlet can be checked when the turbo is accessible. The oil return line should be checked for kinking, cracking, or sludge buildup. Keeping both lines clean and unobstructed is one of the most valuable preventive maintenance steps for any turbocharged Toyota engine. On a turbocharged engine, clean oil in and free oil out are the two conditions that determine whether the turbo survives. Block either one, and the failure is already in progress. Every single habit on this list costs nothing to fix. No parts, no special tools, no dealer visit. Just changed behavior and a small amount of attention at the right moments. The turbocharger is not a fragile part when it is treated correctly. These engines were engineered to last. The habits are what shorten their lives. If you're enjoying this video, consider subscribing to this channel, and don't forget to like this video. Thank you.